Hello, it's Mr. Burnett here. We're going to be doing some stuff on domain and range. I put this on Schoology. It's 3-1 Relations and Functions, page 89 of your textbook. But I put the PDF file on your Schoology account. It should be page 4 on the PDF file. All right, so what we're learning here is domain and range. This is going to be a decently long lesson, so buckle up. Here we go. Domain and range. It starts with an input-output table, which you all have seen before in other classes, probably 8th grade math, 7th grade math. But it starts right here with this, this domain and range input-output table. Okay, so first thing we need to know, what is a relation? A relation is a set of ordered pairs, and a function is a relation when each input is assigned to only one output. That means if I plug in the number 1, I'm only going to get one answer. Okay, so if I plug in number 1, I'm going to get 11. If I plug in the number 2, I'm going to get 12, 3, 13, 4, 13, 5, 13. For any time I plug in one of these numbers, I'm going to get one specific answer. Now, as long as your x values do not repeat, so as long as you don't have 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, whatever, you should be good to go. So for every one input, there's one output. Okay. Something you need to remember, the fact that there are multiple 13s down here in the range or the output section of the table, that is perfectly fine. That does not matter. The domain of a function is the set of inputs. So your x values, your input values, are going to be your domain. And your range is going to be the set of outputs. So that would be your y values, okay? So this is your domain, is your x's, and your range is your y's. So inputs are typically going to be x values, and outputs are going to be y values, just like we see in all this algebra that we've been doing with equations and whatnot. So what you need to learn here is when you're trying to write the domain of something, you're going to write it in this notation right here. So let's go ahead and do this together real quick. So let's pull out this table here. Good enough for me. And what we're going to do now is I want to pull out and let you know these are my inputs, these are my outputs, okay? So if we're going to write domain, you're going to do it like this: a D, a little colon, a squiggly, and you're literally going to write your input values. So 1, 2, 3, 4, 5. Squiggly, okay? Your range values are just going to be your y values or your output values, okay? So you're going to do 11, 12, and 13. There's no need to write your 13 multiple times, okay? And this is what you're going to want to write when they ask you for a domain and range, or when I ask you, or if it's on a test. Pretty easy to remember. Your domain is going to be your inputs, and your range is going to be your outputs, okay? Pretty simple. So let's do the try-it problems here. We have 2 try-it problems. Let's work them together real quick. We're going to do number 1A. It says identify the domain and range of each function. Okay, so we're going to do the same thing we did just now. So we're going to have a domain. We're going to have a range. Little squiggly, little squiggly. Our domain is going to be the x values. So 2, 3, 4, 5, and 6. And your range is going to be your y values. 0, 1, 2, 3, and 4. Okay, simple as that. Super easy. I'm not going to do B because it's the same idea. I think you've got this under control. So let's go ahead and go now down to page 90, or page 5 of your PDF file I attached. And now we're going to talk about some function stuff. As you can see here, it says a function can model each situation. What is a reasonable domain and range of each function? So what is a reasonable domain and range of each function? So let's look at this one first. We have a hose fills a 10,000-gallon swimming pool at a rate of 10 gallons per minute. So when you're trying to figure out function tables, you need to ask yourself, what depends on what, okay? Is the pool going to be 10,000 gallons no matter what? Yes. So it doesn't really depend on anything. Now, the way you're filling up the pool does matter because you're doing it at a rate of 10 gallons per 1 minute. So in 1 minute, there's 10 gallons. In 2 minutes, there would be 20 gallons, okay? See how that makes sense? And now we just plug them in. 3 would be 30. Now, one question you always want to ask yourself, can this work with fractions? Can I have 3.5 gallons? Right? Or 3.5 minutes, I'm sorry. 3.5 minutes. And that's true. Yes, you can. That would just be 3.5 minutes. So if each half minute's worth 5, that would just be 35 gallons. Okay? So this is going to work regardless of if you're using fractions or not. So let's think of some stuff that might not work. What would not work? Well, you can't use 0 because you can't have 0 gallons. So it can't be 0. And it can't be negative. Sorry, I should have put can't be negative. It can't be negative because you can't have negative minutes or negative gallons. So it's not going to be negative. It's not going to be 0. So your domain, okay, would be all real numbers. So we're going to do 1, comma, and we're going to think about it. We can do fractions. We can do all real numbers. We can go all the way to what number? If we can do 10 gallons per minute, we want to think about our minutes. How many minutes would it take to get 10,000 gallons? Well, you just got to divide the two. So this is all numbers 1 to 1,000. Okay, so all numbers 1 to 1,000. That's how we're going to write it for now. I'm going to teach you all a more proper way to do it later, but that's what I'm looking for down. And our range would be, you can start at half, you can do whatever. So we're pretty much going to go from 0 to 10,000. All right, because your bottom is going to end up reaching 10,000 at some point. That's the first example. So reasonable range is from 0 to 10,000 gallons, and a reasonable domain would be from 0 minutes, the time it takes to fill the pool. So it's pretty much what we said. This one, a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. That would mean you would have each table can have 4 chairs, but you cannot purchase. You can't go to Walmart and buy half of a table, right? So these are going to all depend on whole numbers, 1, 2, 3, 4, which is called natural numbers. Those are your numbers that you use to count, okay? That's an easy way to remember. They're counting numbers. And on this one, you see you're not going to be able to use fractions and stuff. And that's what this information here is going to be useful for. So the domain of a function is continuous when it includes all real numbers, okay? If it's a line or a curve. This was the example of the water. It's going to be a line, right? So a line is going to be continuous. But if it's discrete, it's just a set of numbers or integers, and it's data points. So this is little points on your graph for the tables. So if I had one table, I'd have 4 chairs, 2 tables, 8 chairs, but you can't have 2.5. So there's not going to be a point right there. That makes this one discrete, okay? So let's think about these two real quick. This is going to be my last example I'm going to do. Let's do A. A bowler pays $2.75 per game. So what depends on it? The money is what depends on the games, right? So we have games and money, games and cost. Okay, so one game, that's going to be your X, cost $2.75. And we don't even have to do a lot of work here. I'm so sorry. That's awful. One game cost $2.75. Okay, 2 games would cost $5.50. And now we just need to think. You don't even have to do any more math. Just think to yourself, if you played 2.5 games, do you think the bowling alley is going to charge you for 2 games or 3 games? It would charge you for 3 games, right? They're not going to let you get off by just charging you for 2 games. So you cannot play fractional games when you're dealing with this function, okay? It's all going to be multiples of 275 down here, and this is all going to be whole numbers. So this one is going to be discrete, okay? Because you can't have fractions. So you're just going to have on a graph, you'd have a point here, a point here, a point here, but it's not going to be a line because there's no point here or here. That's what that means. So this one's going to be discrete. But the next one, in B, a car is traveling 25 miles using 1 gallon of gas. So 1 gallon of gas is 25 miles. That's your X and that's your Y. Can you do 1.5? Yes, you can do 1.5 gallons of gas. If you go to the gas station and pump your gas, is it going to be 1.5 gallons? Can you do that? Absolutely. Okay, my point on this one would be you don't have to do anything else. You know that's 25. You have 1.5. There's a solution there. You don't have to figure that out. 2 is 50. You just know it's possible. Okay, and since it's possible, you can picture the graph like this. You can say, well, 1 is 25. 1.5 would be here, 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 here. There's going to be dots everywhere. It's going to form a line. Okay, so that forms a line, so this is going to be continuous. And that's the difference between discrete and continuous. So we're going to stop there at the end of page 90. I do want you all to read some of this, and we're going to be doing this, but it's not due until Wednesday. So we'll talk about this a little bit more tomorrow. Thank you.